Hello everyone, thank you for attending this session. I'm Dr. Jordan Allison, Senior Lecturer in Computer Science at the University of Gloucestershire, and I'm currently serving as Editor-in-Chief of the Journal of Educational Computing Research. Today I'm going to introduce RAISE QI, which is a reporting quality instrument that extends the Reporting AI Studies in Education, or RAISE, framework. Rather than providing guidance only for authors, RAISE QI enables systematic assessment of how completely AI in education studies are reported. My presentation will explain why this instrument was needed, how it's developed, and how it can support researchers, reviewers, editors, and for helping with evidence synthesis. So, artificial intelligence research in education has expanded quite rapidly over the last few years, but this growth has also highlighted some substantial variability in reporting practices. Important methodological information is frequently omitted, including details of the AI system, human involvement, ethical safeguards, implementation context, and the evaluation procedures. Without this information, it becomes difficult to reproduce studies, compare findings across different papers, or to conduct some robust systematic reviews. Ultimately, incomplete reporting reduces confidence in the evidence base. So, to address these issues, I previously developed the Reporting AI Studies in Education framework, or RAISE. The framework consists of 30 reporting recommendations organised into 10 thematic areas. Its purpose overall was to help researchers report AI in education studies more transparently and consistently. It originates from my role as editor of a leading edtech journal, and I frequently saw papers that did not include all the methodological information that you'd expect for a study that involved AI as part of the intervention. So RAISE was, in essence, a way to help provide some guidance to authors in addressing some of these concerns. RAISE has moved beyond being a proposed framework and is now being actively adopted by the research community. It's been incorporated into the submission process for the Journal of Educational Computing Research, demonstrating its practical value for supporting transparent reporting. It's also received some broader recognition from the Editors-in-Chief of Computers in Education Artificial Intelligence, who described RAISE as a highly comprehensive reporting checklist that addresses the technical, pedagogical, and ethical dimensions of AI in education research. In terms of use, it's been applied across a wide range of educational contexts so far, including language learning, creative writing, and programming education. Researchers, however, have adopted it in different ways and to varying level of effects. Some use a complete framework for reporting and risk assessment. Others include the supplementary ethics and risk matrix as appendices or supplementary materials, while other authors integrate it into their methodological reporting. And some just selectively apply some specific checklist items to address AI risks and unintended consequences. Overall, though, these examples demonstrate both the flexibility of the framework and its growing acceptance within the field. However, although RAISE provides guidance for reporting, it doesn't provide a way to evaluate whether published studies actually adhere to those recommendations. In other words, a reporting guideline does not mean it is completely effective as a quality assessment instrument, and that distinction is very important. Reporting guidelines and frameworks such as RAISE, they tell authors what should be reported. Quality instruments, on the other hand, allow reviewers to evaluate whether those items have actually been reported and to what effect. So existing reporting guidelines across healthcare and education often inspire quality assessment tools, but as far as I'm aware, there's very few equivalent instruments that currently exist for AI in education. And this represents the methodological gap that motivated the development of RAISE QI. So, the objective of this study was to develop a methodological extension of RAISE that enables systematic assessment of reporting quality. Specifically, I sought to transform every reporting recommendation into an observable assessment criterion. So the resulting instrument is intended to support several different stakeholder groups. Researchers can use it during manuscript preparation as a self-assessment checklist, using it alongside the original RAISE framework if they wish. Peer reviewers could apply it when evaluating submitted manuscripts. Similarly, journal editors could use it to improve reporting standards during editorial decision-making. And finally, systematic review teams could employ it when assessing reporting completeness across already published studies. So ultimately, the aim was to move beyond narrative guidance towards a more practical and reproducible evaluation framework. So, in terms of the development methodology, the development of RAISE QI followed a structured methodological process. Initially, I began with the original 30 RAISE checklist items or RAISE recommendations. And each one of these recommendations was carefully examined to identify how it could be transferred into one of these observable assessment criteria. This promotes consistency because it encourages reviewers to ask the same question regardless of the study that's actually being assessed. Following this, the core reporting expectations were extracted for each of those 30 checklist items. This defines exactly what evidence reviewers should look for within a published article. The third component is an auditor scoring framework, full, partial, or no inclusion. This allows reviewers to judge the completeness of reporting rather than making a simple yes or no decision. For example, if a recommendation states that researchers should describe the AI system, different reviewers may interpret that requirement differently. So one reviewer may consider a brief description sufficient, whereas another reviewer may expect more detailed technical specifications. To minimize this variability, RaiseQI translates each recommendation into 3 criteria, so reviewers can evaluate observable evidence rather than just subjective impressions. As I said before, this approach increases consistency across reviewers and improves the potential for iterative reliability. In other words, 2 independent reviewers should reach similar conclusions when applying the RaiseQI instrument to the same paper. Throughout development, maintaining fidelity to the conceptual intent of the original framework was, of course, essential. The goal was not to redefine the RAISE recommendations, but to make them more measurable. So, the resulting instrument contains 3 main elements for every reporting recommendation. As a reminder, there is 30 checklist items. This slide just shows 3 as an example. So, the first that you'll see on the left-hand side is the item, which is from the RAISE checklist. So, it's the item and the actual description. Next to this, in the third column along, is the assessment question that's been adapted from that original RAISE item. Then is the proposed scoring scale. You'll see score is 0, 1 or 2. Okay, so the scoring framework is ordinal rather than binary, and this is to reflect the reality that reporting quality often exists along a continuum. Some studies report information comprehensively, others report only partial information, and some will omit that information entirely. So using ordinal scoring allows reviewers to distinguish between these 3 different levels of reporting completeness. And what you'll see in the right hand side is where a reviewer would give a score. 0, 1, 2, or it might not be applicable at all. So this instrument therefore provides richer information than just a simple checklist. It can identify partial compliance as well as complete adherence. So if I just take the example of AI model specification, the original RAISE checklist item asked researchers to report details such as the AI model name, version, provider, and whether the static system, adaptive system, or it's a generative system. In RaiseQI, this recommendation is converted into that assessment question, i.e., is the AI model sufficiently specified for readers to understand the technology used? Reviewers can then evaluate the level of reporting using those 3 examples in that ordinal scoring system. So here, a score of 0 indicates the AI model can't be identified or is described only in very generic terms. Such as we used an AI chatbot, a language model, for instance. A score of 1 would reflect more partial reporting, where the model is identified but some important technical details may be missing. A score of 2 represents complete reporting, where sufficient information is provided to understand and potentially reproduce the AI implementation. That same process is applied across each of those 30 RAISE checklist items. So the principal outcome of this research is the development of RaiseQI. It represents, to my knowledge, one of the first reporting quality instruments specifically designed for AI in education research. The instrument enables systematic assessment of reporting completeness across all 30 RAISE recommendations, and it has several practical applications, should it be adopted. So for researchers, it functions as a pre-submission quality assurance tool, allowing authors to self-assess their own work prior to peer review, which can be useful in identifying any potential gaps in their work. Authors can identify those missing reporting elements. Peer reviewers, it offers a structured framework that improves consistency during manuscript evaluation. And for journal editors, it supports that higher reporting standards across published articles. What is quite interesting though is how it is potentially useful for anyone that's conducting a systematic review or a meta-analysis, as it enables reproducible assessment of reporting quality across large bodies of literature. Finally, for the wider research community, improved reporting enhances transparency, reproducibility, and confidence in published findings. From a practical perspective, as an educator, if you don't understand how an author of a research article has actually used AI in education, how can it actually be adapted by educators in practice? They need those full details, and RaiseQI can help with that. So these potential applications extend well beyond the original purpose of RAISE as a reporting guideline. However, while the development of RaiseQI represents an important methodological contribution, instrument development is only the first stage. The next step is that rigorous validation and evaluation. So several different properties should be evaluated. First is reliability, such as inter-rater reliability. Do different reviewers actually produce consistent scores? This is an important factor to understand whether the wording of those scoring systems for each RAISE item is accurate or not. Second is the validity, construct validity in particular, in terms of assessing whether the instrument genuinely measures reporting quality. Here it might be useful to get some feedback from editors to actually assess what they denote as quality in terms of reporting. The third aspect is usability, and that determines whether researchers, reviewers, authors actually find the instrument practical and straightforward to apply to a published manuscript, or indeed in a manuscript they're about to write to help identify any potential gaps. So future studies should also evaluate the instrument across different AI and education research designs, whether that's qualitative, quantitative, mixed methods, and indeed experimental studies. These validation studies will help establish the scientific robustness of RaiseQI. To conclude, AI in education research continues to expand rapidly. However, inconsistent reporting remains a major obstacle to reproducibility, evidence synthesis, and confidence in published findings. While the RAISE framework provides valuable reporting guidance, it was not designed to evaluate reporting quality systematically. RaiseQI addresses this limitation by operationalizing all 30 reporting recommendations into measurable assessment criteria, structured questions, and an ordinal scoring framework. The resulting RaiseQI instrument provides researchers, reviewers, editors, and systematic review teams with a practical method for evaluating reporting completeness. Future work will need to focus on evaluating and validating RaiseQI as an instrument itself and its wider application across AI and education research. But ultimately, I hope that RaiseQI contributes towards improving transparency, reproducibility, and the overall quality of evidence in this rapidly evolving field. So thank you very much for your attention, and please reach out to me at jallison1@gloucesterac.uk if you would like to discuss the Reporting AI Studies in Education framework in greater detail.